like refer to the math notes box, or when I've typed in to your homework, check the math notes. All of the math notes are in this packet for the entire chapter. So when we're going through lessons and there's like a math notes box, these are in order with the chapter. So I decided to pull these off of the homework sheets so that even if you turn your homework in, you've still got this math notes box. Right? I realize like some people turn homeworks in and then all of a sudden it's like, well, crap, I can't refer back to that because I turned that homework in. So on the front here, you'll see a review with how proportions relate to percents. This is a really good review for some of us that are forgetting that part to whole relates to percent being out of 100. Right? When we turn things into a percent, the whole is always 100. So I get that the cars are cute, but for a moment we need to focus on a little bit of class, then we'll go play with the cars. So you want this out, put your name on it, and obviously we got examples from class. Uh, 627. We actually checked it yesterday, and I forgot to do that in the afternoon class, but 627 is due. 6 closure is due. So all things chapter 6 should be turned in by the end of today. If not, they're late. You've had the closure since Monday, so 2 days is today. So, but we're not doing it right now. So gents, I don't know what all the conversation is about. So if you need to come to math lunch, come to math lunch. I'll open the door, we'll do some work, we'll take some other questions. Yeah, the Chromebook that you're going to need is for when we go out into the family room, so you can use like a stopwatch or a timer, like not really even app, but you can just Google it, right? You can Google like stopwatch or timer or something like that. Yeah. Yeah, if you have a watch, there you go. Yeah, but most people don't have watches these days, so Vincent, you're just over-prepared, which I love. So, you may have talked a little bit about this in science. And guys, I think I might keep this table in my classroom, so I realized if I have a table that rolls, it's just going to be fun. So, you may have learned a little bit about this in other classes, but here on your paper, you've got 7-1, and it says, how can George figure out where the train is? Now, wait, what? How can George figure out where the train is? Because we need to tell you the story first. So, if I can have your attention, it's story time now. Yay! So, I feel like I need like a big book that I can turn around and show pictures, but sorry, I don't have a big book that I can show pictures of. So, George drops his sister off at the train station. And if you've never been to a train station, they're pretty cool. So George stood on the train platform, waved goodbye to his sister as the train pulled away. Right? Trains are very consistent, so once they get up to their speed, because they're on tracks and they don't have traffic, they stay at the same speed, right? Once they get to that speed. All right, so later, as George was driving home, he saw a light flashing inside the train station, heard an announcement that his sister's train had malfunctioned and was stuck on the tracks. Now, obviously, train tracks you can follow, right? We know where train tracks go. So George has a map. He knows where the train route goes, and he decided to drive to go pick up his sister who's stuck on this train that is broken on the tracks. So talk with your team for a moment. How could George figure out where the train is? Talk with your team, write down some ideas. Nope, he can't call her. But, hey, when traffic things happen, the cell phone towers sometimes crash. Like when there was a big crash on 315, our cell phones wouldn't work here. Too many people were trying to make calls. Check it. New chapter. So I'm shuffling, and I got a new idea because some people were complaining to me. We're going to put a Post-it note on the first card that I pull, and then I'm not going to shuffle again until we get back around to there. So, Marina, you want to give me some ideas from your group? Your group, you and Layla? Ooh, so hold on. Let's make sure we got some things written here. Save this space. But here, Marina, I heard you say, what was that S word? Speed. So what was the speed of the train? Right? Was it one of those bullet trains that goes like 100 miles an hour? Or was it like a regular train that goes like 30 or 40 miles an hour like we see coming through Worthington here? Eve, what were some things your group discussed? Ooh, how long? So, how long? We often talk about, like, time. Carmen, what about your group? Yeah, I don't know if there's much more to really talk about, actually. We said if we know the speed of the train, if we know how long the train has been going for, Aiden?
How fast can the car go in miles? Because trains are faster than cars.
Well, now the train is slower than the car because it's stuck. But yeah, you're right. Trains are normally faster than cars. At least cars can, you got to speed up, slow down, speed up, slow down. Trains can just go. Vincent?
How windy the track is?
Ooh, if the track is like straight or line, so like the path that it has to take, right? So, I have it on this other screen. You guys are so much better than me. All right, whatever. Yeah, thank you very much for the reminder. I'm just going to leave the recording. Today's option is pancake breakfast lunch, and you do have your chicken patty options, not your burger options. So, pancake breakfast lunch. Hands up high. 10, 11. Wait until the very end there, Eve. Chicken patty, regular chicken patty. Regular chicken patty. None. Spicy chicken patty. Spicy chicken patty. Cheese pizza. 1. Pepperoni pizza. Pepperoni pizza. Just 2. Sun butter and jelly. Classic. Sun butter and jelly. Guys, so if you packed your lunch or you're not getting lunch, so I only got like 14 accounted for. All right. So, you have a car in front of you. Ooh, so the time, so like start time. So I'm going to draw an arrow over here. So when it started, like how long it had ran before it stopped. These are all great ideas. So, with your car in front of you, I want you and your team to discuss how you could make a prediction of how long it will take to go 30 feet. Now, here's the deal. We're going to have a race, but our race is going to see whose group can make a more accurate prediction. So what I'm asking you to talk about is how long, and we'll probably talk like in seconds. I doubt we'll need minutes. How long in seconds to go 30 feet? We'll use feet because we're in America. Even though it like breaks my heart, we will use feet. Also, I thought about using meters, but meters and like minutes both use M's. So I don't know. I thought feet might be better. Talk with your team, take like a minute or two, and then I've got some stuff set up in the family room that we can go do some like data collection with. You can't go yet. Talk with your team first about what you would want to be able to know. And you can't say turn it on and let it run for 30 feet. You can't say that. I tested them all this morning. It should work. Yeah, so when we turn it on, it'll go.
No, I mean like you just need to
Oh, it's not chargeable. It's like batteries that can die. So I mean, it is how much charge it has. All right, this will probably work. We need one person in your group to be able to have a timer. So on your Chromebook or on a watch, not on a cell phone because your cell phones are in your lockers. Listen, out in the family room, around the post in the middle, 3 sides of the post, I have marked out 10-foot segments. Also, on this, the 8th grade side of the family room, coming from the hallway part into the family room onto the carpet, I've also marked out a 10-foot segment. You are allowed, with your group, to collect data only about that 10-foot segment. Capiche? Quit ruining the movie. Alright, let's go out to the family room. Except you said what you said really loud in front of the whole class.
Yeah, we could totally do the third one. Because that one's like a good number.
All right, talk with your team to decide what your prediction for 30 feet is.
It'll be 21 seconds and 68. So, what was it? 7.0.
All right. Antonella. I'm trying to really intentionally use cards, guys. Remember, you can pass, right? I always want to remind you guys, like, no pressure. Antonella, can you tell me why we didn't just do one time trial? Yeah, it might, like, something might have goofed up on one of them, right? So having multiple trials lets us check for, like, accuracy or any like, weird flukes, right? Which we sometimes call an outlier if we get a data point that doesn't really match. So if we wanted to average our times, that's an option. Or you can take the time that seemed most legitimate. What you want to be writing on your paper is either the time you got, oh wait, what was our distance here? 10 feet. So either the time that you guys had over 10 feet, or you could put your distance on top, which is normally how we talk about speed, and you could do 10 feet over the time that it took. I want your team, if you haven't yet, calculate your prediction for time it will take for 30 feet. Oh.
Final, like, thing for, like, it's 30 feet.
30 feet. Yep. All right, so my request, if you haven't set it up as distance over time, let's do that. So if you haven't set it up distance over time, let's do that. Layla Graff, can you tell me how long it took your car to go 10 feet? So like 7.5 if I round. All right, hold up. Bring your focus back. So when we talk about speed, speed is what we call a rate. So, guys, if you aren't used to having highlighters for math class, I don't know why. But right here, in this sentence, we say if your toy travels at a constant speed, then your distance your toy has traveled and the time it has taken are related to each other proportionally. This is what our whole lesson is about today, right? Proportionality. In a proportional relationship, we have what is called a constant of proportionality. Guys, again, that's just a fancy way to say the speed. The constant of proportionality, when we're talking about like problems like this with cars or trains, it's a fancy way to say the speed. So, here we can call it rate, But we can also call it speed right there. So if I was you highlighting some stuff, I would highlight that. But when we talk about speed of cars, Kylie's not here today, right? Vanessa, when we talk about speed of cars, how do we normally say the speed of cars going? Miles per how many hours? 1. So guys, hold up. Your speed, quote unquote, your rate needs to be referencing 1 of whatever our time is. So if your team hasn't done this, calculate how long could you go in just 1 second. And here, since I have 7.5 on bottom, how do I turn 7.5 into a 1? Divide by 7.5. So I'm going to take my numerator value and do that with it. So you guys probably want to do something similar. Whatever number you have, which I heard a lot of us are close to 7. So if I'm using Layla and Lucas's car, I'm going 1.3 repeating feet per second. Your car will probably be different. If I come down here and write the same thing, how, Farah, how could I predict 30 seconds either based off, how could I predict 30 feet? Well, if I had this 10 feet up here, can you tell me how I could predict 30 feet? Well, yeah, but don't drop it again. Farah, do you know how I could go from 10 feet to 30 feet? Hey, can you chill? Yeah, we can multiply because in proportional relationships, we're allowed to multiply on top and bottom. So just like up here, I divided on top and bottom. What I hope we all did to find our 30 feet was multiply by 3, right? From what we had out in the family room. If we multiply that by 3, so I get, for Layla and Lucas's car, 22.5 seconds. The important thing is that your labels match. If you have feet on top, we have feet on top. If we have seconds on bottom, we have seconds on bottom. It has to match. Labels have to match. Now, if I let it go for a certain number of seconds, could I figure that out? Yeah, I can figure out anything I want here. As a team, decide on your final prediction. And then we're going to go test it out. I'm going to be the official timekeeper, though. I'm going to have to charge my phone before later. All right, grab your car. You don't really need much else. You can bring your paper and pencil with you if you want, but we're just going to, well, actually, one of your teammates, bring your paper so you can tell us your prediction. One of you bring the paper so we know your prediction. Yeah, I think that one has, like, new batteries. Oh, yeah, I had commented to my wife about that. I was like, oh my gosh, these 7th graders are funny. Other people write on there, like, I've already told you no. Like, I'm asking them on a date. That's a couple of my Math 8 kids do stuff like that, too. Where it says date on your homework, he's treating it like date, like go on a date.
I was like, what?
All right, so, anyone want to comment or complain about something that they think messed up the proportionality? Yeah, I assumed that your group would want to. Vincent?
It turned.
What do you, okay, so say more.
It turned when it was going, so that messed it up because that makes it go longer.
Ah, so Vincent is saying if I turn,
So wait, can we try and do it without a turn?
maybe, but like I'm trying to fit a certain amount of stuff in a certain amount of time. So we might be able to run back out there at the end of class. But if their car angles, their distance will not be an accurate 30 feet. So what they're complaining about is their time was a tiny bit over. But if their distance was like 31, right? If their distance was like 31, of course their time is going to be longer, right? So if they curved, if they turned and went further, their time would be further. Any other comments or complaints? We had at least one group that was less than a second off. Comment, complaint.
We were 40 milliseconds off.
Why are you complaining then?
No, because
You want to be even closer?
yes.
So, guys, any proportional relationship can be scaled exactly like what we just did, where you multiply or divide on top and bottom. So, solve these 3 questions. Sorry, instead of 300 centimeters, do 300 inches. Uh-oh. Because we didn't take our measurements in metric. We took our measurements in American. This is not on your paper. Sorry, this is why we always need graph paper out, right? The inches is kind of your challenge.
Hey, Vincent, give me a graph paper, please. Okay. Thank you.
You guys thought because we were in chapter 7, for some reason we don't need graph paper?
No, I'm just like, maybe they're giving us a break from graph paper.
Oh, why would I do that? That's silly.
I'm used to hating graph paper.
No, you don't. It's a really tough thing. Like how you saw that I was like trying to figure out where my pen went.
looking for? 9 seconds?
Yeah, but that wasn't working out as well. It was harder for the kids, so I put them on worksheets to make it easier for you guys. Easier, right? Can't make math easy for you, but I can make it easier. I did. But I said I can't. I didn't say I can't make it easy. How, Eli, how is your group solving for 9 seconds? Okay, so from the 1 second, what'd you do then? So if you have your time or your distance for 1 second, how do I get to 9 seconds? Times 9. You want a rematch? So actually, the 300 inches, we'll leave that as a challenge. But I do want to solve like one more problem together. So Bella and Edward, anyone get the reference?
Yeah.
Bella and Edward are sitting across the cafeteria from each other. Now, guys, we know when you pass notes, at least most of the time. So Bella and Edward have thought up a new system. They're going to hide their note under their car. Right? No one's going to notice the car wheeling across the cafeteria. Perfect way to pass notes. So, Hold up. On your graph paper, John, you're killing me, man. On your graph paper, if we know that Bella's car travels 1.1 meters per second, how long will it take her car to travel the 20 meters to get to Edward with the notes? So talk with your team on your graph paper. What we should be setting up is a fraction equal to another fraction.
That's really fast.
Right? 1.1 meters per second. Seems pretty quick. We normally put distance on top and time on bottom. So if you want to get in that habit, we normally put distance on top, time on bottom. Distance on top, time on bottom is the better way. Guys, who is that? Stop it. You're just making noise. It's not helpful. Amanda. Nope.
Good morning, Phoenix. Please pardon the interruption. If the following students could please stop by the office for just a moment. Amelia Hudson, Douglas Miranda Magella, Chloe Reichenball, Liliana Smith, Anna Sturts, and Isis West. That's Amelia Hudson, Douglas Miranda Magella, Chloe Reichenball, Liliana Smith, Anna Sturts, and Isis West, please. Thank you.
Amanda, the 20. The 20. If I'm trying to put that over here, would that go on top or on bottom? Why? You're right, but why? Yeah, 20 meters. If I put distance on top, my 20 meters has to go on top. Now, some of you are probably like, that's a pain. It would have been easier, but math ain't easy. If it was on bottom, that would have been nicer math. How do I go from 1.1 to 20? I don't know. How do I figure that out? Division. So grab a calculator. If we don't know what to multiply by, we divide backwards. So we're going to do 20 divided by the 1.1. 18.18. Leave that in your calculator. 18.18. Repeating. We don't have to say it over and over again. We just use the bar.
Calculator's cheating. I is not only.
So then we do the same on the bottom.
Which you get.
Times 18.18. What does multiplying by 1 do? Nothing, so it leaves it the same. Oh, I should write this in green. What label would 18.18 get? Seconds, because the label has to match. Guys, if you're not writing this down, you're probably going to struggle on your homework. And no one will notice the little car driving across the cafeteria for 18 seconds. Nobody's going to notice.
It's possible.
And then Bella's note will get to Edward.
I have a note for you.
Yeah. Hey, don't break it. Questions. Sorry, I should have questions on this. Proportional relationships can always be set up and solved using multiplication or division.
You forgot the bar for the bottom for 18.18.
Sorry. The repeating. The repetend. Yeah. Good catch. The repetend is what we call that. I thought you meant the Let's see if we got time for this. Here's your important info. Yep. Gloria's toy travels 40 centimeters per second. Actually, do you want to do Gloria or David? Let's do David. On your graph paper, if David's toy travels 35 centimeters per second, how far will it be after 20 seconds? Let's solve for David's toy. So, on your paper, we're just practicing another proportion. We normally do distance over time. So, 35 centimeters over our time of 1 second. Notice how having 1 second on bottom is kind of nice. Makes some of the math easier. John, where would 20 seconds go? On the bottom now, because it's seconds, right? Instead of our 20 meters, now it's 20 seconds, so it goes on bottom. How do I get from 1 to 20? Times 20. So we do the same on top. Guys, what's 35 times 2? 70. Then put the extra 0 on. 700 centimeters. That is all I got for you today. Guys, please turn in your Chapter 6 homework today. If you don't have it done, come to Math Lunch. Thank you very much. I'll come around and get your cars. Yeah, but you got enough stuff to get going to your next class. Did we leave a car out there? No, I think we're good. We had 6 to start. We said car F is no good?
Yeah. It's like really slow. It's bad. That was fun.
Aw, that's a good F word. Love hearing class was fun. Yeah, it's okay. The battery's probably starting to go, right?